Welcome back. We're in lesson 77 in Algebra 2. We're going to talk about some advanced radical equations and having to deal with multiple radicals within the same equation. So far, we have limited ourselves to one radical or one square root type problem within an equation. So the way we would solve this is we know that this means the square root of. So the way we get rid of a square root is by doing the opposite. And the opposite is an exponent, right? So therefore we would apply the exponent, and we would do that to both sides because we have to keep the equation true. So if we square this side, we have to square this side. Well, we know that squaring and the square root cancel each other out. So this becomes x minus 1. And this becomes 4 times 4, which is 16. Thus, it allows us to solve for x by adding 1 to both sides. X is equal to 17. And then to see if this is true, we turn around and put this back into the original statement, which was x minus 1 equals 4. So if we put 17 minus 1 equals 4, we know that 17 minus 1 is 16. And 4 does equal 4, right? So we're able to prove that statement and that process through that series of solutions to this equation. As a final step, like I said, we checked it and we made sure that it was indeed true. And it can be shown that if both sides of an equation are raised to the same power, whatever the index is here, the solution of the original equation, if any exist, are also solutions of the resulting equation. This permits us to solve the radical equations by isolating the radical and then raising both sides to the whatever power is indexed by the radical. And we know that if there is no number given here, that the default is 2. And it's only whatever, if there's a number here that's different, that we would change that. Otherwise, we use 2. So let's solve 77.1 and see exactly what this is talking about when we have the radical symbol involved, when it's something other than a square. So we have an index of 3 on this problem, and it's x cubed plus 6x squared minus 4. That is what is under the radical sign. And then we have minus x minus 2 equals 0. So what we're going to do is we are going to add x and 2 to both sides. So we get x plus 2 over here, and these cancel. So we are left with this radical symbol of x cubed plus 6x squared minus 4 equals x plus 2. So what we're going to do is we are going to counteract this by raising it to the power of 3, which makes the 3 here and the radical symbol cancel out. We're going to do this to the same side, or same thing to the other side, because we have to keep the equation balanced. So that's what we're going to do. So what we end up with on this side, because all of this cancels, is x3 plus 6x squared minus 4. Now we have to find out what this is. So if we do the math, we say x plus 2, we get 4, we get 2x plus 4, we get plus 2x, and then we get an x squared, right? So that becomes x squared plus 4x plus 4. Don't forget there's 3 of them, 1, 2, 3, so we have to do another one. X plus 2, 2 times that is 8, is a positive 8, positive 8x, positive 2x squared, and now we have a positive 4x, positive 4x squared, and an x cubed, okay, because x times x squared. So we write that on this side, and we say x cubed plus this becomes 6x squared, this becomes 12x, and this becomes 8, right? Let me scroll this up so we can see what we got better. So x cubed plus, that's how it combines. So we write that over here. So we have x cubed, 6x squared plus 12x plus 8. I'm going to double check with my book. Yes, it does the same exact thing. So that's what we got, what we have now. So now what we can do is we can solve, right, for x if at all possible. So let's add 4 to both sides. All right. Let's look at subtracting this. That's a 3. Okay, so those cancel. If we do this, these cancel. Actually, so instead of subtracting 4 from both sides, what if we subtract 8? Let's subtract 8. All right, so then this cancels, so we're left with negative 12 is equal to 12x. So when we divide both sides by 12, we get negative 1 is equal to x. All right, and that is our solution. So we can go back in and check that based on the original equation. And our original equation would be, let me write it up here, index of x cubed plus 6x squared minus 4 minus x minus 2 equals 0. All right, and it was supposed to be a negative 1, right? So the third index of negative 1 plus 6 negative 1 squared minus 4 minus a negative 1 minus 2 equals 0. Let's see. This is going to be a negative 1, right? This is going to be negative 1 times negative 1 is positive 1, so it's plus 6 minus 4. This is going to be plus 1 minus 2. So that's going to be negative 1 equals 0. All right, so we have negative 1, positive 6 is 5. 5 minus 1 is 1. So the third index of 1 minus 1 equals 0. Well, the third index of 1 times 1 times 1 is 1. So 1 minus 1 is indeed 0. So that is correct. All right, so that is how we would solve one of those complicated problems. We would just take the radical and whatever the index is, we use that as our, instead of a square on both sides, we use it as a exponent of 3. So just make whatever's in the radical match whatever you do to either side to get rid of the radical. That's all you're doing. It's just instead of using 2, we use the indexed number. Easy peasy. You guys are smart enough. You can intuit that yourself really well, I'm sure. So when an equation contains more than one of those radicals, what do? It is sometimes necessary to square both sides more than once to eliminate all of the radicals. So we begin by rearranging the equation so that it makes sense to do that. So we're going to look at the equation here. This is 77.2. We have k minus 5 minus square root of k plus 1 equals 0. So the first thing we're going to do is rearrange so that k minus 5 is by itself. And we do that by adding the square root of k and subtracting 1 from both sides. All right, so that cancels, that cancels. So what we have left is k minus 5 equals the square root of k minus 1. So we're going to square both sides because there's no number here, it's a square. So we square this side and we square this side, and I probably shouldn't put that here, I should probably put it here. So this cancels that. So this is k minus 5 equals, and so now we have to figure out what this is, right? Because this is not under the radical that's -1. It is going to be a separate creature. So we need to come over here and sort it out. So the square root of k minus 1 times the square root of k minus 1. Negative 1 is positive 1. This is negative k. This is negative k. And this is a k. So plus k. So now we have negative 2k plus 1 plus k on this side. All right, so now we're going to combine these with this side. We're going to subtract k, and then we are going to subtract 1. Subtract k and subtract 1. So these cancel, and we're left with -6 is equal to -2 times the square root of k. We divide both sides by -2. We get that 3 is equal to the square root of k. So when we square both sides, we get that k is equal to 9, right? So let's go back and see if we could put that into our original equation and it be correct. So the original equation had k minus 5 minus k plus 1 equals 0. So this should be the square root of 9 minus 5 equals 9 plus 1 equals 0. So let's see. This is going to be 4 minus, this is going to be 3, this is going to be 2 plus 1. 2 minus 3 is -1. -1 plus 1 does indeed equal 0. So this is correct. 9 is the value of k. All right. Let's do one more just to make sure we've got the hang of it. I'm going to let you guys try this one. This is 77.3. We have the square root of x minus 8 plus the square root of x equals 2. So I would like for you guys to, or you ladies, to pause the video, solve for x the best you can, square everything that you need to, and you're going to have to do it twice, and then press play and see if you got the right answer. I feel confident that you will be able to do this. This is fairly straightforward. So just take your time, think things through. It is logical in its procedure, so go for it. And then check back here as soon as you're done to see if you got the right answer. I'm going to pause my video as well, and I'm just going to solve it out, and I'm going to put the right answer up so that you guys can see where I'm coming from and where you might have made a mistake without having to wait for me to solve it. All right, so if you got that x is equal to 9, you're only halfway right. That is what x solves for. However, we do the process just like we're told to. We subtract the square root of x from both sides. That leaves us x minus 8, square root of x minus 8 on this side. And on the right side, 2 minus the square root of x. So we square both sides, and we get x minus 8 is equal to -4 square root of x plus 4. We subtract x from both sides. We subtract 4 from both sides. That cancels the x on this side and makes a -12 equals -4 times the square root of x. We divide both sides by the -4. We get that 3 is equal to the square root of x. So when we square both sides, we find that 9 is equal to x. So if that is what you got, then that is the right answer for the value of x. However, when you check your answer and you sub in 9 for x, we get 9 minus 8 is 1. The square root of 1 is 1. The square root of 9 is 3. 1 plus 3, however, does not equal 2. So we have no solution. There is no solution for this problem because when we put in what we think is the solution, it does not check out. It does not make a true statement here. And that is why it is important. You have to sub your value that you solved for back into this type of equation in order to make sure that your answer is correct and that it is the true solution. Sometimes you'll get more than one answer, and more than one answer will potentially, one of those will potentially not be correct, while the other one might be correct, right? So sometimes this is going to happen, and if this happens, what you need to put in Jupyter is no solution, right? So always double check what x equals and make sure it actually does make the statement true, because it is possible to find an answer that doesn't work. All right, that's all we have for lesson 77. I will see you in lesson 78.